Assalamu alaikum everyone. Welcome to Fundamentals of Programming course. In today's session, we will be talking about a function called by reference versus function called by value. But before jumping on to that, we need to understand one little concept in C++ that is of a reference variable. Till now, we have seen how we can use simple variables in our programs. What we need to do is that we need to define the variables and initialize the variables, just like first we write its data type, second we write the name of the variable, and third we initialize that variable with some value. What this statement does is it allocates a memory space of 4 bytes to this particular variable, names this space as first, and stores the value 9 in that space in the memory. Similarly, if we define another simple variable, what happens here is that another box of memory is allocated to that variable. That box of memory is named as second, for example, here, and the value is initialized to 7. This was how we used to define and initialize simple variables. Now we will be looking at how we can define reference variables in our programs. Reference variables are themselves not a space in the memory. However, they serve as a reference to some other variable in the memory. For example, here none of these two variables was a reference variable, so the two different boxes were assigned to these two variables in the memory. However, in a reference variable, a reference variable is not itself a space in the memory. It just serves as a reference to some other place in the memory, i.e. It serves as a reference to another variable. So what we have done here is we have defined and initialized a simple variable named first, and initialized it with value 8. What it has done is that it has allocated a memory space of 4 bytes that is initialized by 8, and that memory space is named first. However, when we will be defining a reference variable, it will be a little bit different from the definition that we are doing in our simple variables. This was our simple variable, just defined just like these two. However, when we are defining our reference variable, we have to put the ampersand sign along with the variable name or the data type name. For example, here when we are defining a simple variable, we just used to write int the name of the variable equals to some value. And so what happened here was this particular variable was initialized to the value 8. However, reference variables are not initialized to a value. They are initialized to some other variable to which they can serve as a reference, hence the name reference variables. So here we can see that when we are defining a reference variable, we need to write the reference sign along with the variable name, and that sign is represented by ampersand. Similarly, we have the data type here, integer, then we have the reference sign, and then we have the variable name, and the reference variable is always initialized to some variable. What does this mean? This means that this variable 1 is serving as the reference to the variable first. For example, before we had defined our reference variable, the memory was being named only as first. However, when we are defining our reference variable 1 and initializing that variable to another variable first, what it does is that it makes 1 as the reference to the same memory space that was being named first. Now this space in the memory has two different names. This space can be accessed through the name ref first, and also through the name 1, because 1 is now the reference variable that is initialized to the variable first. So this is a small concept of reference variables. you can develop a small analogy like that. When you have your favorite characters in shows or seasons or movies, you reference them through their character's name mostly. It is very rare that you are referencing them with their actual names. The, the name their name in the movie or a show serves as a reference to their actual name. Similarly, here this reference variable serves as a reference to the actual name of the variable, and both of these names can be used to manipulate the data of this particular space in the memory. Now we will look at the difference between call by reference versus the call by value. Till now we have seen how we can use our functions in the program was through call by value. We used to send the variables value into the other variables defined in the definition of the function. So let's first look at how we can do the call by value. There are three steps as we discussed in the last sessions: the function prototype, the function definition, and the function call. It is important to notice what happens when the function call takes place. We know that in the function definition and the code, what the code does is written, and in prototype certain specific details of the function are written. Function call, in function call we just name the function and send whatever arguments it is expecting to receive. For example, in this example we had the function cube that was expecting one argument, and that will return one integer value after performing the cube on that particular value. Here what we were doing, basically we were receiving an argument in the variable num, and just multiplying it with itself 3 times to take its cube, and then returning that particular value back to the main function. So the important thing here is to look at how the function call takes place. Function is called by its name, and the argument number is sent to the function where it is received in another variable num, named num. So before this call we had the variable number that was holding the value 5. Now as soon as the function call takes place, what is basically happening here is that this statement is the equivalent of int num equals to number. Int num equals to number, and we know that when we write any statement just like this, what this statement does is it moves the value stored in the number variable to the variable num. So there will be another box in the memory that will be named num, and will be holding the same value as the variable number. Number was holding the value 5 here. Here num will also hold the value 5, and it will be another space in the memory. So this statement is basically equivalent to when we do the call, this statement basically is equivalent to int num equals to number. And there are now two variables both with different names, number and num, in the memory. Although their scope is of course limited, num is limited to this scope and number is limited to this scope. However, there will be two different variables that will be present in the memory. Now we do the cubing of the argument that we had received in the variable num. We cannot use the number variable because its scope was limited to these two brackets. We perform the operation on the variable num and return the variable num. Now here at this stage number still has the value 5. There has been no change in the value of number variable. However, the num variable has been updated to 125. So we need to return the num value here. When we do the return num, this is basically received back here, and the result is stored in the variable result and then printed. Since we were calling the function by values, so we need to write the return statement. What does it mean to call the function by value is that here the value of this variable number was being passed to this variable num. So this function call, this is the call by value that we are talking about. Now let us look at how we can do the call by reference. Similarly, there are three different steps in call by reference. First is the prototype writing, second is the definition of the function, and third is the function call. Now this function call is a bit different from uh, how we are calling the function when we are making use of call by value. We saw just a while ago that we can define reference variables in addition to the simple variables that we have been defining up till now. Those reference variables just serve as the reference to the some other memory space in the memory, and they themselves are not occupy any space in the memory. For example, here we were what we were doing was int num equals to number. So what this was doing was generating another variable named num and assigning the value stored in number to that variable num. However, when we are calling by reference, what we need to do, firstly we need to change up our prototype a little bit to just like we simply used to write int when we were using call by value. We need to write int ampersand sign, that is basically the representation of reference operator, int, and in our prototype also the variable that will be receiving the variable that will be here at the function definition will also be a reference variable, because we are doing call by reference. And just as this statement was equivalent to int num equals to number, this statement becomes equal to int reference variable is equal to number. So int reference variable num equals to number. So what does this statement do? This statement is a bit different from this statement. This statement used to allocate another space in the memory named num, and that space used to hold the value of the number. However, as we know that the reference variables do not occupy some space in the memory themselves. They just serve as a reference to some other variable. Same is the case here. Another variable num will not be initialized in the memory, just as here it was defined in the memory another variable named num. However, when we are using num as a reference variable, defining it as a reference variable and initializing it to the variable number, what happens is that the same memory location that was being accessed through the name number can now be accessed through the name num as well, because num here was a reference variable. So it did not occupy any space in the memory itself. It just served as the reference to the already defined variable number in the memory. So what happens here is that another variable named num also points to the same memory location to which the variable number was pointing. So now whatever change we make in the variable num or the variable number, it is basically equivalent to changing the data at that memory location. For example, here what we did was we multiplied the num with itself 3 times to have its cube, and the value got stored in the num. So now the num variable holds the value 125, but num is pointing to the same memory location as the number was pointing at. So basically number has also been updated. We have accessed the variable number through the reference variable num. So this memory space that can be accessed both by the variable number and the variable num has now been updated to the value 125. Here we had two different variables, number and num. However, in call by reference, another variable does not get generated. This reference variable just serves as a reference to some other variable. So whatever change we will be making in the reference variable, that will be made in the actual variable number, because both are technically pointing to the same memory location in the memory. Here there is an important thing to see. For example, here we needed a return type integer. However, in this case we do not need a return type, because we do not need to return anything back to the main function, because it has already been updated to that value. Here the number was not updated, and here if we had not returned anything, what would have been the value that was stored in result here, because because we were printing the result, so it was important that we return something back to here so that it gets stored in the variable result. However, when we have used call by reference mechanism, we do not need to return anything, because although we are printing the variable number here, the same variable has been updated through the reference variable num. So it is not that we are writing num here, it is that we are writing number here, but number also points to the same memory location that was updated, so there is no need to write the return statement here, because the updation is valid for both the reference variable and the actual variable. So this can be used where we need to return more than one value back to our functions. In a disguise, this is basically returning a variable, returning the cube of the number back. However, there needs not to be written a specific return statement, just like we needed here. We needed to write the return statement here, and we could write only one return statement as far as the things that we have learned so far are concerned. We can only return one value from our function if we are doing the call by value. However, when we are doing the call by reference, we technically do not have to write the return statement, so we are in a way not limited to returning any number of values that we can return back to the function. This similarly, another if the square was happening as well in this function, we could have updated the two different variables here, one doing the cube and other doing the square, and both would have been sort of returned back to the main function, because the updation would have been made into the variables that was done through the reference variable.